Hi everyone. Good morning. Very good morning, guys. Good morning, all of you. How are you all? One second, guys. Right, Sunita, Prasad, Supriya, Praneet, and the two others, Anjali, Ramesh, Shruti, Shravan, Tajamal, Rakesh, Gopi. Good morning, everyone. Very good morning, all of you. How are you all, guys? Everyone, how are you? Everyone, how are you? Fine? Very good. So, all of you had your tea, coffee, hot water, juice, everything? Tea, coffee, hot water, juice, breakfast, everything is over? Not good? Why? Why? What happened? Yeah, motivational study. Ranjit Vishwakarma, good morning. Very good morning. Right. So actually, the day before yesterday, we could not do the class fully now. So today we'll be continuing that. And on the day I was not feeling well, so it happened like that. But now it's okay. Right. So quick concepts of which one this and PYQs of RCC. So that materials and specifications part 5 we are discussing, right? Mostly today and tomorrow class, with this class, this first chapter gets over, we'll be entering into the design philosophies. Okay, right, all of you, welcome to Unacademy. Let's crack it, right? Everyone ready to crack? Everyone get ready to crack, all of you, right? Here so here this is my profile, and what is the referral code you have to use? RPC will is the referral code you have to use, and you recommend the same referral code to all your friends, juniors, and everybody also, right? Now these are all SSC JE and state A toppers from 2022, right? You also have to get your name next time on this pamphlet, okay, on this PDF or PPT, whatever it is, a presentation. Okay, now at present this offer is going on, so 20% off plus 4 months extra free extension you will be having on your subscriptions, and this offer is valid up to which one? This August 12th, so 3 more days only will be there. So if you are taking 12 plus 2 months, this is at this price you will be getting 6,400. 24 plus 4 months if you take now, so 11,580 you will be getting it, you can say. Okay, so RP Civil is the code you have to use. Nagalakshmi, good morning. Inform to your friends, juniors, and everybody, those who are willing to prepare for the state examinations, right? So here KP sir, myself, and Amit Jaralo sir also will be teaching in this, you can say, right? Amit Jaralo sir also will be taking the classes, but he will be taking only RCC subject. Remaining all will be taken by KP sir and myself, right, in the plus courses, right? But don't worry, it will be started later. It will take some time for Amit sir to start RCC class. That's why I have started this RCC in the special classes. Okay, so you have to be careful. He'll start in the plus again, don't worry. Okay, no need to worry about it. Okay, so RCC will be taken by Amit sir, and these are all the subjects. Is it lag for everyone? So these are all the subjects taken by myself, and remaining all subjects are taken by KP sir, right? Building materials will be taken by KP sir only, right? So RCC only will be taken by Amit sir, and remaining all KP sir and myself only. Okay, right? But it will take time, so that's why I am starting which one? I am starting that RCC in the special classes now itself. Okay, right? Coming to this, so these are the major changes you'll be having in which one? This SSC JE. Have you all applied for SSC JE? Any of you did not apply for SSC JE? Have you all applied for SSC JE? So don't miss this, right? Everyone, you have to apply for SSC JE, right? If not applied now, if not applied till now, you start applying for SSC JE, all of you, right? If not applied now, you start applying now onwards, right? Yes, now don't miss this, right? Now Airport Authority of India, these are also posts you are having. This is a recorded batch available for this. Whenever you are enrolling for this, right, use the code RPC. Now these are the plus courses we are doing, right? These are the free classes we are doing, you can say. Okay, right, now coming to this, before that, So those who are enrolling, those who are willing to start your preparation, you can just enroll for this batch, right? Samarth batch, right? Once enrolled, tell me all of you. I'll try to move. Once all of you enrolled, tell me. We'll try to move forward. Once everybody enrolled, tell me. Deepika, good morning. Right, so this quick concepts and PYQs of this RCC, that is materials and specifications chapter. Okay, right. Here design, RCC design, materials and specification first chapter, right? So these are all the things we are discussing now. Do you remember? I am just recapping. So here, what is it? These are the codes corresponding to various codes, various grades of this steel you are having. And what is this? Sand blasting also we have discussed yesterday. If you just remember, sand blasting part also we have discussed, everyone, if you observe. And this elastic modulus and how to calculate this elastic modulus also we have seen. If you remember, all of you, is not? Do you remember that how to calculate this elastic poles, elastic modulus? Do you remember? If it is not giving, right, if it is not giving that exact, right, if it is not giving the exact one, just from the graph, right, what you can do, you have to go it from which one, everyone, you have to observe it from which one, you have to observe it from this 0.2% value now, is or no? You have to observe it from this 0.2% value, everyone, right? Is not? Corresponding to this 0.2% strain parallel to the initial straightness, initial straight line, you will be drawing which one parallel to this initial straight line, right? What is that you will be doing? You will be drawing which one? You will be drawing a line and it will be intersecting that main stress strain curve at some location, right? That will be taken as what, everyone? So that will be taken as which one? That will be taken as your proof stress or this yield stress, right? So why you are calling it as a proof stress? Because you are proving it now. Because we are proving it, it is called as your which one? This proof stress now, everyone, is not like that. Right? And why I said this will occur at this place, if you just observe. Why it will occur at this place, if you just observe? It will occur at this place because at this 0.2% strain, because there will be the particles will be little becomes loose at that point, right? It's not in strength of materials, that is discussed in very detailed manner, don't worry. But here that is the main reason you are having. Okay, right? Simply corresponding to this 0.2% only, it cannot offer little resistance for some time, right? So you can say, Ashwin, good morning. No. So this is what we are supposed to discuss from today. No. So these are the typical stress strain curve for this mild steel and this HYSD bars. These are the typical stress strain curves for which one? This is a mild steel and this is HYSD bars, if you just observe, right? So for this mild steel, you will be having this curve in this manner. So here this lower yield point itself will be taken as your yield point, or not all of you? That lower yield point itself will be taken as your yield stress, or not all of you? Lower yield point itself will be taken as your yield stress, if you just observe, right? Is not? Right? Why lower yield point only will be taken as your yield stress? We don't take this upper yield point, right? It's not. You have to be careful. And in case of this stress strain curve for this FE4 and FE500, what is it you will be having? So corresponding to this is 0.2% means 0.002. You just draw a line parallel to the initial straightness and it will be intersecting the curve at some location. Then this will be taken as which one? This FY, right? That will be taken as your which one? This FY. This is intersecting the original curve, right? This is the characteristic original curve. It is intersecting at which one? This FY. That will be taken as your FY value, if you just observe, right? Is it clear? All of you? So how it will be taken? So but now do we use this? So here don't worry about these values, right? These things I will be discussing in the limit state method of design. So other curves don't worry, right? But this one it is important, right? Just for this one only I have taken this slide, right? Weight of this bar in kilogram per meter, right? What is it you can say? Pi square by this 162.2, right? Pi square by 5 square by this 162.2, right? What is it? Phi you can say? Phi is the diameter of this bar in millimeter, right? How you are getting this, if you just observe? How you are getting this? Yeah, this 5 square or this d square by this 162.2, right? How you are getting this, if you just observe? Weight is nothing but your volume into that weighted density. What is the volume you can say? Volume is nothing but your length 1 meter, right? It is already given as 1 meter na per meter na weight of kg per meter, right? So weight is length is 1 meter given already, and so weight area, cross section area, how can you get that? Pi by 4 into that 5 square, right? If you simplify everything, you will be getting only in terms of this diameter na 5 square by this 162.2, right? Directly you have to go for this, right? Like that. Is it clear? Right? So you just write this equation and tell me, everyone, once it is noted. I'll try to move forward. Just to note down this equation only, right, in this slide. Don't write anything else, right? This right side also don't write, right? Because we are going to write them in the limit state method of design, right? How they will come, right? What is the story behind that? I'll explain the limit state method of design. Just you write only this one, weight of this bar in kg per meter. Once noted, tell me. We'll try to move on to the next. Noted, all of you? Yeah, yesterday how many questions we have got completed, everyone? How many questions we have got completed in yesterday's class? Anybody remember the number? Question number? What is the question number? We are done up to yesterday's class. Anybody? I don't remember the question number, right? Anybody remember? Okay, so nobody, right? Select the answer for this first question. Don't write the answer, try to select it. Okay, I'll write 1. Yeah, nobody remembered. Nobody from YouTube? Gopi, Sunita, Shruti, Tajamal, Supriya, Anjali, Naglakshmi answered correctly. So this is a leaderboard. Right. Gopi first, Sunita second, Shruti third. Yesterday means day before yesterday. Okay. Yesterday means day before yesterday. What was the question number? Okay. This is the second question. Select the answer. So that is why I have mentioned the CTQs and PYQs, right? Both, okay? Because some concepts will be learning through questions and some quick concepts, and after that we'll be doing PYQs, right? All mix. I told you no already. Arey, what happened here? Arey, my screen not visible. Arey Baba, my screen has gone blank. One sec. Now it's okay. The screen is visible. This is a leaderboard. Shruti first, Tajamal second, and Sunita third, right? So so sand blasting is used for which purpose? Somebody check yesterday question number. So sand blasting is used for which one? This is a cleaning of this reinforcement only, no? Yes or no? It is she is cleaning of this reinforcement only, no? Cleaning of this reinforcement only, right? Is no? Now don't worry, right? Don't worry, no need to worry about it, right? I told you, right? That is why I said just before starting the poll for this question itself, I said, right? So some concepts we will learn through questions, some concepts we will learn before and solve the questions, right? That is why I said I know these kind of questions will come. Okay, don't worry. So reinforcement bars must be stacked at a minimum height of, right? So dash above the ground level to avoid the rusting and this is scaling, right? So what is the meaning of this scaling? Have you observed what is that scaling? First of all of you, have you observed what is the meaning of this scaling? whenever you are having which, right? Whenever you are having which one? So whenever you are having this, right? Whenever you are having that heater, have you observed this heater, water heater? Have you observed this water heater, everyone? So whenever you are observing this water heater, na, right? In this water heater, so when you are heating it continuously, that white color one will be formed, na? Right? That white color one will be formed or not? Isn't it? The what is the white color one, if you just observe? That is your scaling formed or not? That white color one is nothing but your scaling, you can say, right? The white color one is nothing but your scaling, if you just observe, right? Is it clear? So you have to be careful. So minimum, so it is better we have to keep them on the ground, or it is better we have to keep them at some distance from the ground, you can say. It is better we have to keep them at some distance from the ground. Na? Minimum at how much distance we have to keep them? Minimum at 150 millimeter distance we have to keep them from the ground. Na? These are the reinforcement bars. So that what will happen, that ground wetness will not come on to this, and they will not be affected easily, right? They will not be affected easily, right? But in the field, if you just observe it, what happens, they'll be just keeping it openly on the ground. Na? Is it a correct way, or it is not the correct way? Actually, it is not the correct way of putting the reinforcement bars. Okay, you have to be careful. Now, so this is the next question, right? Third question, right? Try to identify the answer. Right, 62% only answered, right? Because that question is not discussed, that part. Shruti first, Sunita second, Supriya third, right? So identify the correct statement from the following, right? We have seen that a sand blasting, right? What is that sand blasting, everyone, if you remember? We'll be sending the compressive air inside, and along with that abrasive material, that is the sand we are sending inside. So then what happens, that abrasive material will be rubbing the surface of this reinforcement bar, so that a rusting part will be eliminated, and they looks like this very new model, very new material like the look they will be having now. Isn't it? That is a sand blasting we have mentioned, right? But what is that a short blasting, if you just observe? Instead of this compressive air, if you are using the centrifugal force, then it is called as your short blasting. Is it clear? If you are using the compressive air, then it is called as your sand blasting. Okay, if you are using the compressive air, it is called as your sand blasting. But instead of this compressive air, if you are using that centrifugal force, right? How this centrifugal force will be useful? Whenever you are rotating it continuously, right? What will happen? The particles inside also will be rotating because of this in this curved manner, and they will be moving like this. They will be subjected to centrifugal force now. So from this center, the particles will be moving towards the edges because of the centrifugal force. After hitting them, they will come back again, right? So because of the centrifugal force, again they will move from center to the sides. Again, after hitting the sides, they will come to the center, right? Like that. So moving from center to ends, center to ends. So when that ball is moving like this, subjected to centrifugal force, it will happen or not, everyone? So instead of this compressed air, if you are using this centrifugal force, then it is called as your short blasting. Okay. The term short blasting refers to the process of propelling abrasive material with the centrifugal or this mechanical force, right? The term sand blasting refers to the process of propelling that abrasive media with compressed air, right? Is that clear, everyone now? All of you? So the difference between this sand blasting and this short blasting is clear. The difference between this sand blasting and this short blasting is clear, everyone? So some questions, some concepts we'll discuss through questions, some concepts we'll discuss first and solve the questions. So like that, it's a mix, okay? Mix kind we'll do, okay? Don't worry. So nobody is telling the question number, how many questions we have done previously. So that means nobody was right. All are cute fellows, right? This one also, just go for. So whenever actually I was searching for reinforcement bars in the Google, I found these images. Array, it is better I should give one kind of question on this. Then I thought I have given this. Right. So this is a letter about Sunita first, Shruti second, and Supriya third, right? Yeah, before that. So tell me where this scaling will occur, tell me. Where this scaling will occur generally? This scaling will occur in case of what? This coastal areas mainly. Na? Yes, you can use any abrasive material, right? Only the way of propelling or way of forcing the abrasive material is different. Okay, you can use any abrasive material. You can use sand or you can use any abrasive material, right? Because sand is available freely, we can use that sand. Okay, that is best way, right? Only the propelling mechanism is different. We are sending the air with force, that is a sand blasting. When you are what is the main intention? Abrasive material has to hit the main member, it has to rub the main member, that's it. It has to move along the main member, that's it, like this, right? How can you do this? Either by means of air or by means of this centrifugal force, right? If you are using it by centrifugal force, then it is called as your shot blasting. If you are sending it by this compressed air, then it is called as your sand blasting, right? In both also we can use the sand, there is no issue, right? So in this coastal areas or this long shore, right? Shore means what? What is it shore, everyone? So river shore or this sea shore, right? Everything, na? Yes or no? Long shoring area. In this area, that scaling problem will come daily, mainly. Okay. So now tell me which of the following is incorrect practice while storing the rebars. First one, can we just keep it open like this? Just now we have mentioned, is it okay to just keep it open like this, or it is not okay to keep it open like this, right, on the ground? It is not okay to keep it open, and it should not be touching the ground, na? But practically, if you just observe in all the construction fields, it is like this only. That is a wrong way. Okay. If you say to them, na, hey, I am civil engineer and I am following IS 456, and so IS 456 is telling like that, RP sir is telling like that, we should not store it like this. Then that what that contractor as this in charge will say you whenever you are joining your job for the first time, he'll say that, अरे यार you are छोटा बच्चा और छोटी बच्ची, so I am doing this work since 20 years, कुछ नहीं हुआ मेरे structure को, nothing happened to my structure, you are coming and telling, right? Like that he will say, is not? Yeah, I think 20 questions. Okay, this way is okay or not? This second way is okay or not? So I think this fellow is good fellow, right? He is storing the reinforcement bars at some height from the ground, right? This way of storing is okay or not okay, everyone? This second one, first one is okay or not okay, all of you? Number one, hello. First one is not okay. Second one is okay or not okay? Second one is okay, right? But this is a third way. Second one is okay, right? Third way, why second one is okay? Because we are keeping at some height and we are just covering with some covers, so that what will happen, that atmospheric wetness also will not create problem, right? So this is best way na among these two. And here, so sometimes what will happen, if you are pausing your construction, you wanted to continue this construction for which one? This after 2 years or 3 years, let us say, right? So you are having only money for construction for ground floor, then what you need to do, you just don't keep these bars open. So what we need to do, either you just go with this cement, right? Just cement or this any color, you just paint it, so that what will happen, rusting of it will not come now. But if you are keeping it open like this, whenever a rain comes now, so that rusting will come, and this kind of this red color liquid passing like this now. Have you observed this? Now here that kind of problem will not be there, right? So which one is better among these two? This left one is better or this right one is better? This left one is better or this right one is better? Everyone tell me. This left one is better, obviously, na? Yes or no? Left one is better, obviously, right? So now tell me which one are not the correct ways among these two given? Among these four given, right? Which one are not the correct ways? 1 and 4 are not the correct ways, na, everyone? 1 and 4 are not the correct ways, you can say, right? Like that. Is it clear? Shall I move to the next? So this completes your reinforcement. This completes your which one? This reinforcement material, right? So we are left with which material? So we are left with which material? You can say that we are left with the main material, right? What is our main material? If you just observe, that is what is our main material? That is concrete. Okay, in the RCC, reinforced cement concrete you are calling, right? Means with the improving the strength, it is a cement concrete is only the main material, right? So now here if you just observe concrete, whenever you say concrete, which grade of concrete you are using? So I am discussing only the points which are required for RCC point of view. Okay, I am not discussing all BMCP point of view. You have to be careful. So there are, according to the old table, so these were the concretes, right? M10 to this M25 ordinary concrete, M25 to this M55, this is the standard concrete, and M60 to this M80, this is which one? This is high strength concrete, right? This was the according to the old specification when we were studying. Okay, but what is a characteristic in the designation? Specified characteristic compressive strength of 150 mm cubes at 28 days in a Newton per millimeter square, right? So what is that? M10 means 10 MPa, M15 means 15 MPa, M20 means 20 MPa. So now tell me, what is that a number in the grade representing? That is representing the characteristic compressive strength of this concrete, or not everyone? That is representing the characteristic compressive strength of this concrete, right? Yes, now that is representing the characteristic compressive strength of this concrete, if you just observe, right? So characteristic compressive strength of this concrete at which age? At a 28 age, na? Yes or no? At 28 days age or not? Yes, at 28 days age it must be, you can say, right? So you have to be careful, right? It is at which one? At 28 days age, you can say, right? Why at 28 days? Do you remember? Already we have discussed that point, right? Because by 28 days only it will be getting almost 98 to 99% of the strength. Remaining 1% strength it will get in the lifetime. Okay? So it is better we'll go for this 28 days strength, right? The designation of this concrete mix, M refers to the, concrete mix, M refers to the mix, and the number specified compressive strength of 150 millimeter size cube at 28 days expressed in Newton per millimeter square, right? As now you have to be careful. You have to be careful, right? You have to be careful, you can say. So here, whenever it is a cement strength, if you wanted to say, what is the cube size we are using? 150 millimeter cube size, that is 15 centimeter cube size we are using, or which centimeter cube size? What is the cube size for cement strength? Yes, 7.05 or 7.07 centimeter cube size we are using now, right? So for concrete compressive strength greater than this M55, design parameters given in the standard may not be applied, and the values may be obtained from the specialized literature and experimental values, right? You have to be careful, right? So up to this we go for which one? So up to this we go for which one? This is a nominal mix. Up to this we have to go for this nominal mix, and here we have to go for which one? This is a design mix, right? For this standard grades simply design mix we are using. And for this what we need to do? For greater than this M55, right? So refer the literature, right? What is it we have to refer? We have to refer the literature and journals. So IS 456 has given specifications how to do this, or IS 456 has not given? IS 456 has not given for this, no? Is that no? Refer literature, right? Like that. Is it clear, everyone? So this kind of question also may be asked, right? So which of the following grades are referred? Which of the following grades of this concrete are referred? Which of the following grades? For which of the following grades mixed design is done as per which one? Mixed design is done as per mixed design is done as per the IS 456. IS 456, right? Which one? For standard grade of concrete, now. And for which grade of concrete journal papers and research papers has to be referred? For M60 onwards, now it is as per the old table, right? And as per the new table, right, what is that you can say, everyone? This is that a new table now according to this amendment 4, right? After amendment 4 is done, there are many amendments we are having. So you might be studying now. Yes or no? In the polity also amendments to constitutional amendments we are having, right? So for different kind of amendments, different majority is required, and so we can do. So many times these amendments are done to the constitution. So similarly for these standard specifications also amendments are done many times, right? So amendment 4 has given this new table, right? Ordinary concrete M10 to M20, right? Is there any change from the previous one or no change? No change now. M10, M15, M20. And standard grade of concrete M25 to this M60, right? So that M60 has brought to this one, right? So standard grade only. Now high strength concrete M65 to this M100. Previously it was which one? This M80 only, but now it is which one? This M100, right? Why I am giving this a new list as well as this old list is, tell me how many numbers you are having in this totally. Ordinary concrete, how many grades are there? 3 grades are there in the old one. Standard concrete, how many grades are there? 1, 2, 3, 4, 5, 6, 7 grades are there. High strength concrete, how many grades are there in the old code? 1, 2, 3, 4, 5 grades are there. Yes, no? But as per this new, these numbers they are asking the questions. You have to be careful, right? So ordinary concrete always 3 only. Standard concrete now how much? 1, 2, 3, 4, 5, 6, 7, 8, right? So now tell me which one you have to answer. Number of grades of concrete present under this standard concrete category. If that is a question given, right? What we need to do? What we need to do? 7 we have to answer or 8 we have to answer now. 8 we have to answer as per this new specifications now. According to the old specifications it was 7. So how many grades of concrete are present in this high strength concrete category as per IS 46? 5 as per the old category. Now how many? Tell me. As per the new category, 1, 2, 3, 4, 5, 6, 7, 8, right? This is also 8, right? So but ordinary concrete it was the same, right? Is it clear everyone? So now, so this is your same, right? Now it is a nominal mix, right? What is the meaning of this nominal mix? Are we doing any design things or we are not doing any design things? We are not doing any designs. We are just directly giving the mixed proportion of coarse aggregate, fine aggregate, cement. This is a standard concrete. We have to do it by which one? This is a design mix, right? We have to calculate the proportion of this cement to fine aggregate, coarse aggregate, right? So this, how can you obtain the mixed proportion of cement to coarse aggregate, fine aggregate? Refer research literature. Now same points only given here, right? So here more than M60 means for high strength concrete. So clear everyone? How to decide these mixed proportions of these 3 types of these concretes? So first of all, what are the 3 different types of this concrete? That is important, right? Ordinary concrete is standard concrete and which one? Ordinary concrete is standard concrete and which one? This is a high strength concrete, right? So based on this, right? Based on this, what is that you are having? If you just observe. Yes, research papers are nothing but journals only, right? Journals are nothing but research papers only, okay? Journals are nothing but research papers only, right? After doing research only, they'll be publishing these journals, okay? Right. Clear everyone? Category or the classification of this concrete as per IS 46, everyone? Clear? Noted? Clear and noted everyone? Right. Now coming to this, right? Coming to this. Okay. So what is that you will be having if you just observe? The characteristic strength. We are mentioning that characteristic strength under compression. Na? Characteristic compressive strength means characteristic strength under compression activity. Okay. Characteristic strength is defined as the strength of a material below which not more than 5% of this test results are expected to fall. What is the meaning of this? It is a frequency of repetition of this strength. Here this is your strength on this x-axis, right? So you will be getting the curve like this. So now this value can be represented as which one? This FCK. What is the FCK? Characteristic strength. So characteristic compressive strength, right? So just for an example, for M20, what is the characteristic compressive strength? For M20, what is the characteristic compressive strength of concrete, everyone? That is 20 MPa. For M50 it is 50 MPa. For M100 it is 100 MPa, right? You have to be careful. Yes, now? So means whenever you are having this distribution curve like this, you can call this value only as the characteristic strength which we are representing, because if you are representing this 20 MPa as the strength, now only 5% of the situations strength will be lesser than this, and 95% of the situations that strength will be greater than this, right? So it is better you represent that only now. Suppose if you represent this mean strength, this mean value, right, this value is your mean value. If you are representing this mean value, right, what happens everyone? If you are representing the mean value, so what does it mean? You are saying good morning. If you are representing that mean value, what does it mean? 50% of these results will be having strength lesser than this, and 50% of the results are having more strength more than this, right? Is it okay to represent like this? So whenever you are representing the strength of one mixed proportion, with the same mixed proportion, we have made some 100 cubes, let us say. So which one should be represented as the strength, characteristic strength? That is the strength which is characterizing the mix. The strength which is shown by majority of the cubes we have to represent, or strength which is shown by minority of the cubes? Tell me. The strength which is shown by majority of the cubes we have to represent, na, Shruti? So the strength which is shown by majority of the cubes should be reported as, which one should be reported as a characteristic strength, right? You are telling it as a characteristic strength, but only few are taking that strength. So can you represent that this is a characteristic representation of the group? What is the meaning of this characterization of mixed proportion? Characterization means what? Adapting this particular property to that mix. Is not, Shruti? Characterization bole to kya? Characterization means what? Adapting this particular property to that mix. Okay? So characteristic compressive strength. We are adapting, or we are telling that, Arey bhaiya, if you are taking this mix 1:2:4 something, for example, okay? Don't ask me always it is 1:2:4, okay? Just for example, 1:2:4, it is a characteristic strength will be 20 MPa. What does it mean? If I'll say characteristic strength of this mix 1:2:4 will be 20 MPa, what it should be? It means that many number of these cubes made with this mix should show that strength, or only 5 or 10% will show that strength it is sufficient enough. You are representing the character, means how you will assess the character of a person based on all majority of that fellow's characters, na? So no, based on the quality, major qualities of that fellow only, or minor quality of that fellow only? Based on the major qualities of that fellow only, no? Is or no? So if you wanted to characterize any particular parameter to a mixed proportion, what we need to do? It should be that should be shown by, that property must be shown by majority of these cubes, or that should be shown by this less number of cubes, to say it as a characteristic property. To say this characteristic strength is representing the character of this mixed proportion. It should be shown by majority cubes made by this mixed proportion, or it should be shown by this less number of cubes only. Hello? Majority, na? So whenever you are talking about somebody also, right, you are discussing, hey, yaar, this fellow is good here. So he is in this way he is good, in that way he is good, in that way he is good, right? Overall he is good, but just only one bad thing he is having, right? Just because of the one bad habit of taking cigarette, let us say, you are saying. Nowadays, not taking cigarette is a bad habit, right? People have become like that. Okay? But generally, you will say that, that fellow is having only a bad habit of taking cigarette, right? Remaining all are good qualities only. So, okay, chalta, let it be. Then he is our good friend. So, based on this cigarette he is taking, you say that, hey, he is very bad fellow, worst fellow, you say like that. Or just 99% qualities are good and 1% quality is bad, but he cannot go out of this addiction, and you can say only based on that he will say he is bad. Only based on that you cannot say it is bad, na? Based on the majority characteristics, right? So whenever you wanted to say this mix is showing this much amount of whenever you wanted to say characteristic strength for a mixed proportion, so it should be followed by, it should be shown by majority number of these cubes, or it should be shown by only few number of, only 1 or 2 cubes. If it is showing, it is sufficient enough. It should be shown by majority of the cubes, now. So if you are making 100 cubes, just for an example, if you are constructing, if you are making 100 cubes, manufacturing 100 cubes with this mixed proportion given, right? So 1 is to 2 is to some, this 1 is to 2 is to 3, just for an example, okay? If you are making concrete cubes with this 1 is to 2 is to 3, right? Is not that 95% of these materials are showing, 95% of these cubes are showing which strength, that we have to select it, or 5% of the cubes are showing which strength, that should be selected as a characteristic strength. Tell me everyone, which one, majority or minority cubes? Majority cubes only we have to select now, is or no? Like that. So majority means more than 95%, right? So here only 5% of this results may be lesser than this M20, but remaining 95% of these results will be showing M20 or more than M20, right? So then that value I have to say it as a characteristic strength of that member. Is that clear, everyone? The meaning of this characteristic strength, everyone, is clear? The meaning of this characteristic strength is clear, everyone, right? If you just take 100 samples, right? For this, if you take these 100 samples, whenever you are taking these 100 samples, right, what is that it will show? 100 samples, right? Out of these 100 samples, so 95% samples, what they will show, greater than or equal to that 20 MPa they have to show, is not? And what is that you can say? 5% of these samples, right? 5% of these samples they will be showing which one? This lesser than 20 MPa, na? If they are showing like this, then this 20 MPa, right? Then this 20 MPa will be taken as your characteristic compressive strength. Got it, everyone? The meaning of this characteristic compressive strength. Everyone is clear? The meaning of this characteristic compressive strength, everyone is clear, all of you? Clear, everyone? Anyone having any doubts? Anyone else is having any other doubts? Clear? Shall I move forward? Right. Yeah, 95%, more than, yeah, 95% will be showing which one? This is more than or equal to 20. Then only you can say 20 MPa will be taken as a characteristic strength, right? Suppose for a mix you are preparing, so 95% of these cubes, right? 95% of these samples are showing which one? 95% of these samples are showing which one? This strength greater than or equal to that 17 MPa, and only 5% of these samples are showing which one? This is strength lesser than 17 MPa. Then tell me what should be taken as a characteristic compressive strength of the mix? Then from this, what should be the characteristic compressive strength of the mix prepared? That is 17 MPa will be taken as your characteristic compressive strength of the mix, na? Is that no? So that 17 MPa should only be taken as a characteristic compressive strength of this mix, na? Is that clear, everyone? How to identify the characteristic compressive strength of a mix? Is it clear, all of you, everyone? Clear, all of you, right? Is not? Yeah. Why you are deleting? You are writing options and deleting. Why? Okay. Clear, everyone? Right. Now here, if you just observe, right, this is very, very important, right? Whenever you are going for this, na, yeah, 3 days, no need to delete, right? Keep your comments there, no problem. Yeah, Syed, good morning. So previously it was different, but now according to this amendment 5, you have to remember these values only, right? You have to remember these values only, right? So what is that you have to remember? If you just observe, whenever it is a 3 days, 45% of this is specified strength, right? So what does it mean? F3, 3 days strength will be equal to which one? 0.45 times, it is approximately equal to which one? This is 0.45 times this FCK, na? Or you can also write it as this 0.445 times this F28, na? Because what is the specified strength? 28 days strength will be the specified strength, or not all of you? Yes, absolutely. 7 days strength will be 60% of the specified strength rate. What does it mean? F7 will be approximately equal to which one? This is 0.6 times this FCK, na? So it is equal to which one? This is 0.6 times this F28 if you just observe. So 14 days strength will be which one? This is 85% of this specified strength, right? So what is the F14 is approximately equal to 0.85 times this FCK, right? Or it is also equal to 0.85 times which one? This F28 you can say. Is that clear, everyone? So is that clear, all of you? So 3 days strength for concrete, 3 days strength, 7 days strength, and this is 28 days strength, right? How it will be considered, right? How it will be considered, right? Is it clear all of you? Is not clear? So this is the new specifications, right? These are your which one? These are new specifications, right? But what are the old specifications if you just observe? But what are the old specifications? Do you remember? So that 3 days strength will be equal to which one? Half of this which one? This is 28 days strength. And 7 days strength will be equal to which one? This is 67%. But that is 2/3 of this 28 days strength, right? These were the specifications taken as per the world code. 14 days there is no recommendation for 14 days. But as per the new specifications, 14 days is given. Okay. So which one you have to remember at present now? You remember both, because you remember both, right? Because what happens now? So sometimes these old fellows who are old faculty, old professors, if they are giving the question paper now, they will not be updated and they will be giving according to the old specifications only, right? You have to be careful, right? Just write this and tell me. What is the specified strength? Characteristic compressive strength at 28 days now? Can everyone? One student tell me, all of you. So these are applicable for which one? These are applicable for which one? You consider it. These are applicable for this 150 millimeter cube now. So these are applicable for which one? This 150 millimeter cube only. Okay, you have to be careful. This is also for which one? This 150 millimeter cube now. Right? Once clear noted and once noted, tell me everyone. We'll try to move forward. Noted? Right? Done? Okay, noted, noted. Yeah. Then tensile strength of this concrete, right? So whenever it is mentioned as the tensile strength of this concrete, you may be having which one? This a direct tension will be there, direct tension will be there, and a bending tension also will be there, right? So which one will be considering if you just observe? This is your flexural tensile strength, right? Flexural strength in tension and flexural strength in this tension. So what is it? You have to take it. This is also called as which one? This is a rupture strength. Okay, this is also called as which one? This is a rupture strength, right? Why bending tension we are considering, right? Why not this direct tension? Because is it possible to apply direct tension in the concrete, or it is impossible to apply this direct tension in the concrete, everyone? It is not that much possible to apply direct tension in the concrete, na? Yes or no? So bending tension we can apply, right? So universal testing machine UTM we are having, na? In that UTM we can keep this at the bottom, you can keep this, and you can apply this, na? Yes or no? These are the supports you are having. So at these places you will be having these loads, two loads, right? At this place that is simply supported you will be having, right? So do you remember this, everyone? How to get that flexural strength? But even without getting it, right, how to calculate? Without testing, how to calculate? That split tensile is this one. This is a split tensile. Okay, this is flexure. Have to be careful, right? This is your which one? This is split tensile, right? So you are going for this split tensile. This is your split tensile test, and this is your bending test. Okay, bending or this flexural test, right? So got it, Gopi? The difference between these two. So directly we'll be applying the bending, and this one we will be applying which one? This in one direction we are applying compression. So in this top direction, vertical direction, we are applying compression, right? So what will happen? That vertical compression will result in this horizontal tension in the cylinder, na? So that's why. So this vertical compression will result in this which one? This is a horizontal tension, indirect tension, right? So direct tension we cannot apply, right? Indirectly we are creating the tension here, right? In the split tensile test. But bending tension, directly you are creating the tension, you can say, right? So but how to calculate that? Instead of conducting the experimentation, so we can calculate it directly, that a rupture strength or tensile strength of this concrete, that is FCR. Why you are calling it as FCR, right? Why you are calling it as FCR, right? Because yet this F tensile, right? This F tensile stress in the tension is greater than or equal to that FCR. What happens? First crack forms. Now you understand what is the meaning of this cracking strength or this rupture strength? Rupture strength, or you can also call it as which one? This cracking strength. Is it clear, Shruti, now? What is the meaning of this cracking strength or this rupture strength, right? Because in the tension only that cracks will happen, or in the compression cracks will happen, everyone? Ajit, good morning. In the tension cracks will occur, or in the compression cracks will occur, everyone? Whenever you are having a bending, on the tension side only that cracks will occur, na? On the compression side cracks will not occur, na? So on the tension side cracks will occur. So whenever the first crack is formed, you can say that it is failed, na? Right? Because it is a brittle material. Whenever it is a brittle material, it will show the deformations and fail, or suddenly it will fracture. Suddenly it will fracture, na? Suddenly it will fracture, you can say, right? Yes, na? Concrete is a brittle material. It will fracture suddenly at the time of failure, right? No further deformation. Got it? Clear, everyone? So just note this and tell me all of you. Relation between 3 days, 7 days, 14 days strength with the 28 days strength. Yeah, that is what we are applying. Which one? We are applying compression, right? We are applying compression in the vertical direction. But what it will be resulting in, you can say, it is splitting in the horizontal direction. It is splitting in the horizontal direction. If you just why it is splitting in the horizontal direction? So by means of a crack here, right? Whenever there is a crack here, yes, bending and flexure both are same, right? Bending and flexure both are same. Flexure is nothing but bending only, okay? Yeah, here. So here if we just observe, yes, because it is by means of splitting, it is subjected to indirect tension, okay? So it is splitting means when that splitting will occur. In case of compression, is there any failure of splitting? No. That too it is a brittle material. Whenever it is a brittle material, what will happen? You can say it crushes, but it will not cracks. Is no? It will be subjected to crushing, but cracking will not occur. Is no? But cracking is occurring and that cylinder is splitting into two parts. So what does it mean? Indirectly that a tension is applied, tension is created in this horizontal direction because of this compression in the vertical direction. So tension is created in the horizontal direction that will split the cylinder into two parts. So that is why you call it as which one? This is split cylindrical test. Okay. The tension which is used for splitting the cylinder into two parts, right? That only we are calculating, not the applied compressive force. Okay, is it clear? No, that is what the name itself is giving the answer, right? So once clear noted and once noted. Noted, tell me everyone. Done? Right. Okay, then I'll try to close it otherwise, right? I'll discuss the remaining things in the tomorrow's class, right? Tomorrow mostly this concrete part will be over. Okay, tomorrow mostly that concrete part will be over. Theoretical discussion, only questions we may be having. Okay, right. Shall I close the session, everyone? Right, is everything clear, all of you? Anyone having any doubts? Yeah, Sunita, tell me. You tell me, what is your doubt? Anyone, any doubts? You just ask me now. So tomorrow that remaining strength, the comparison, right? The comparison of we'll discuss, right? Which strength is higher, compressive strength is higher, or cylinder cube compressive strength is higher, or cylinder compressive strength is higher, or split tensile strength is higher, or rupture strength is higher, and everything relation I will discuss in tomorrow's class. Okay, that is very important question. Okay, you have to be careful. Many times it was asked in the interviews also. They'll ask more frequently this one. Even for me also they have asked it in that L&T interview, it seems. I did not take the leaderboard screenshot. Now it will not show. No, after this question was over, only it will show. At this time only it will show. Right? I did not take the screenshot. Okay. I thought we could discuss some questions. Okay. Okay. Thank you. Thank you. So that is why it is better you take and send me, all of you. Once the poll is over, you just take and send me. Yeah, that is better. When I am showing the leaderboard now, you just ask me to wait and you take the screenshot and send me. That is better, okay? Because I'll forget every time. Thank you guys. Have a good day.